Acting Vice-Chancellor, it's a great honour and a privilege to introduce our honorary graduate, Dr. Ron Kaplan. Ron Kaplan has contributed over a span of 50 years to the development of the field of linguistics and the development of applications in language technology based on formal discoveries about linguistic systems. He has held positions of management and leadership in industry and key academic positions, including a professorship at Stanford University for the past 40 years. He holds 36 patents in science and technology, which have had extraordinary impact. Every time you enter text into a computer, phone, or tablet for texting, word processing, or to search for something, you're using technology built on Ron's discoveries. Ron grew up in California and took his first degree in mathematics and psychology from the University of California at Berkeley. Also knowing some linguistics, he was inspired by a quote from Noam Chomsky that envisioned how a generative grammar might be embedded within a model of human language production and comprehension. Ron was a pioneer in both computational linguistics and psycholinguistics. In the early 1970s, he wrote the grammar of the so-called lunar system, which was the first substantial natural language question-answer system. NASA had sent pieces of moon rocks brought back from Apollo 11, brought back 50 years ago next week, sent pieces of moon rocks to lunar geologists all over the world, and then collected the results of analysis in a database. NASA commissioned the lunar system so that their scientists could easily query the database. It was the first time ever that you could ask a computer something like, do any samples contain more than 13% aluminium? And then follow it with, and which are those samples? Alongside this work, Ron completed his PhD in psychology at Harvard University. His PhD research is a very early example of the area we now call psycholinguistics. He then went on to make several foundational contributions to the field of linguistics, co-developing the first constraint-based theory of syntax and co-developing the field of computational morphology. This led him to create and lead the research group for natural language theory and technology at the Xerox Palo Alto Research Center in California. His work there on the core mathematical properties of human language led to his major contributions beyond the field of linguistics. It's easier if I present these wider contributions as two themes. First, the words of language, and then second, the sentences of language as communication. As a scientist, Ron was interested in the theoretical properties of linguistic systems. The abstract investigation of those properties led him to make two significant proofs, which in turn led to technological applications. The first was the proof of a theorem about the computational properties that would underlie a system of spell checking. As a result, Ron helped develop the first spell checkers in the 1980s, producing small portable spell checkers. This further enabled the development of fast small dictionaries. It could be applied to any language, and also to the development of the first electronic books. The second proof was a theorem about finite state transducers, which sounds very dry, but it concerned the computability of the actual forms of words in any language. The finite state technology that was subsequently developed is the foundation of almost every current text processing application. Whenever you enter text into any digital device or do any kind of search, it is the technology that figures out what word or words you intend and in what language. Starting in the 1990s, personal and office computers became ubiquitous, all containing the technology I've just described. More recent developments mean that we now often enter data by speaking rather than by typing, but it's the same data. The other theme of Ron's work is concerned with actual human communication, not just with words. The lunar system built for NASA was fundamentally a search-driven system. It works with facts. But even in the 1970s, Ron was interested in how to develop a different kind of system, a more realistic conversational system. A relevant analogy would be the difference between looking up your medical symptoms in a book or talking to a doctor about them. In the last decade, Ron has worked as a senior scientist for Nuance Communications and then Amazon to develop what he calls conversational search. Nuance is a world leader in speech technology, which is looking to provide smart systems that take over once the speech signal is decoded. Amazon is a company that probably will be known to all of you. Once fully developed, conversational search will mean that we can interact with technology as if we were talking to a doctor or a travel agent, rather than looking up information in a book or a brochure. That's what's coming next. Acting Vice-Chancellor, it is therefore with great pleasure that I present to you Dr. Ron Kaplan for the degree of Doctor of the University, honoris causa.
Acting Vice Chancellor, ladies and gentlemen, I would like to express my deep appreciation to the university for this tremendous honor, and I would especially like to thank Professor Sells for his very kind introduction. I want to offer my congratulations to all of the graduates today in your areas of law, languages, and linguistics. Your parents are rightfully proud of the achievements and accomplishments that this event celebrates. There is always some uncertainty, however, in a transition to a new stage of life. But I think the law and language graduates and all their families probably have a good sense of how they will make use of the knowledge they have acquired in their studies here. For the linguistics graduates, though, the future may seem a little less clear. I can still remember my own parents' reaction when I came home from university about 50 years ago and told them I'd finally figured out what I was going to be. I was going to be a psycholinguist. I could see several emotions flit across their faces: confusion, anxiety, concern, fear. They relaxed only after I got my degree and announced that I'd actually gotten a job. I was hired to be a scientist in computational psycholinguistics at the new research center that Peter mentioned, that the Xerox Corporation had established in Palo Alto, California. In the early 1970s, computers were huge machines that were accessible only to people with very special skills. But PARC, the Palo Alto Research Center, was organized a vision of a personal computer, that there would come a time when ordinary people each would have their own computers and their own computer, and those computers would assist people in their everyday lives. A bunch of engineering problems had to be solved. How to make computers cheap enough so that ordinary people could buy them. How to make them fit under a desk or in a satchel that you could take to the beach. But they also had to have enough capabilities so that the cost and the effort would be worthwhile. So a bunch of engineering problems had to be solved. The engineering was difficult, but that wasn't the most challenging part of the vision. The deeper and more important question was, how are ordinary people, not specialists, going to interact with these personal computers? How are they going to tell the computers what to do? How will they figure out whether the computers had actually done the right thing? We explored two approaches to the problem of computer-human interaction. The easy and most immediate solution was the one that you are all familiar with. PARC researchers developed the mouse, window, icon menu interface that is now commonplace across the world. But clearly, language, is the most natural and efficient way for ordinary people to exchange information and to express most directly their needs and desires. There are things you can convey in language that you cannot communicate by pointing and clicking. So we also set out to create a family of language-based interfaces. This was more ambitious and much harder, and many researchers have worked on this problem over the years. Systems have advanced. There's great value in the search engines, the translators, even the smart assistants and smart speakers that we now use every day. But it is no secret that there are frustrating gaps in what these systems understand. Modern computer interfaces still don't pay enough attention to general linguistic insights and to the properties of particular languages. And that, I think, is a major factor in their continuing poor performance. The skills and knowledge that today's linguistics graduates have acquired are still needed to humanize the ever more complicated technologies that ordinary people will encounter. Beyond technology per se, there is no question that we live in increasingly complex and tumultuous times. As you graduate today, you know that a changing world will present unforeseen challenges and new opportunities. In your time at university, you have all become specialists in your particular fields of study. And you've gained an understanding of human behavior and values more generally. Going forward, I hope you will all find ways to apply what you have learned here to help create technology that is more human and a future that is more humane. So again, I thank the university for this great honor, and I wish you all the best of luck in your future endeavors.